This is a lesson on a variety of questions involving trig ratios, some of the material that we covered recently. And I'm going to begin with calculator operations. Fairly routine things, but you run into them frequently enough, so you want to make sure that you have complete command of them. So, two questions. First one is the sine of 25 degrees. And we want to write this one, answer this one correct to 4 decimal places. And if you take a look in your calculator, you will see you have a mode button, and when you select it, we have the ability to switch to degree mode. Now, up to now, that's all you've been working with in other courses. But in 30 Pure, you need to be comfortable with both degree mode and radian measure, which we'll start looking at very soon. So when you press mode, I'm not going to bring up a calculator for this one, rather just describe it. If you press mode, and then on that menu, you'll see on the third line you have radian versus degree. So take it over to degree and press enter, and now your calculator is set on degree. When you reset your calculator, it will return back to the default radian measure. And you have to watch out for that from here on in this unit, because we'll be going back and forth from degrees to rads, and you always have to be aware of what mode you're in, because it affects trig. Most other calculations are not affected by it, but it does affect your trig. So this is the first time we have to watch out for that. And then all you do is you press sine 25 degrees. And what your calculator is doing, it's measuring, or is based on a measurement of a 25-degree angle in a right triangle. And what is the ratio of the side opposite to the hypotenuse? That's all the sine ratio is. You could actually measure it out if you wanted to, although most don't bother. And you should get 0.4226. Simple as that. Now the next one will involve a reciprocal function. So secant of negative 312. And you do not have a secant key on your calculator, so you have to solve this one using your cosine key, because the secant of negative 312 degrees would be equal to 1 over the cos of negative 312 degrees. Keep in mind that is on your formula sheet. If you should forget it, I don't think you will though. And you enter it in just as it is, 1 divided by cosine of negative 312, and then you'll get your answer. And this works well. There is another way to do it using the reciprocal key, where you go cos negative 312, then you use your x to the negative 1 key. I'm not writing this down, so you won't get to see it, but I'll have a chance to show that later on. But I find this works really well, just 1 divided by that. And you can handle any reciprocal key that you, or reciprocal ratio you run into. Now to change gears a little bit, I'm going to take a look at the quadrantals. And this is not even a specific topic. Not everybody covers this the same way. But it's worth looking at now, because you do run into the quadrantals in a lot of questions in the next few days. I'm going to start off with an example. If the point 03 lies on the terminal arm of a rotation, find the 6 trig ratios. So it looks innocent enough at the start. And if you put it on a grid, this is what you're going to get. Now notice that is a 90-degree angle if you are on the y-axis like that. And when you do see a graph, you can see we've got a problem. When you try to draw a reference triangle to find the radius, you don't really have a triangle to work with. In fact, some of you are thinking, well, how can I even have a 90-degree angle within that right angle triangle when there already is another 90? Well, if you play it by the book though, with x equal to 0, y equal to 3, and you solve for r by using x squared plus r squared, x squared plus y squared is equal to r squared, you will get a measure for r. Now you can also by inspection determine what the radius is, but it will be 3. So we have all the values, x, y, and r. So if we go back to those ratios, we can find out what each of them are. So here we go. Here are the 6. Notice I wrote the reciprocal ones not in terms of their normal, like cosecant equal to 1 over sine. I wrote them as the actual values flipped over. So r over y for cosecant. Secant is r over x. Cotangent is x over y. And now we just plug in all the values. So I've got the first three written up here. And I've switched, instead of just writing it as sine theta, now I'm indicating that this is the sine of 90 degrees, because that is a 90-degree angle. And we get 3 over 3, which is just equal to 1. The cosine of 90 is 0 over 3, just equal to 0. And the tan of 90 is 3 over 0, so that's going to give us undefined. Now what's interesting about that is that this gives us the 3 basic ratios, primary ratios for a 90-degree angle. The sine of 90 is always equal to 1. And your calculator will confirm this if you went sine 90. The cosine of 90 is always equal to 0. And your tan of 90, if you tried working that one out on your calculator, it will shut you down. And so we would say that tan of 90 is undefined. And you can see from the basic, trying to divide 3 by 0, it won't work. Now let's take a look at the reciprocals. And the cosecant of 90 is 3 divided by 3. And that's going to give us 1. So the cosecant of 90 is the same as the sine of 90. It makes sense. It's just the reciprocal. Interesting with secant, when you try to take the reciprocal of 0, you flip that over, you end up with the 0 on the denominator. So once again, you're undefined. And tan 90, of course, we have, but the cotangent of 90 is equal to 0 over 3, so that's equal to 0. And so we do not get the tan of 90, but we do get the cotangent of it. One thing to remember that you'll see in the future, you cannot use your calculator for that cotangent of 90. If you went 1 divided by tan 90, it wouldn't work. So that's that's interesting. You need to really train yourself to recognize that cotangent would be 0 for that figure, and also to recognize that the reciprocal of an undefined value is going to be 0 because it brings the 0 to the top. So that can be a little bit tricky. But what you will see as well, that all the quadrantals, which are 0, 90, 180, 270, and you could consider 360 there as well, all the quadrantals are going to produce values for the ratios of 0, plus or minus 1, or you would have undefined values. So they're quite recognizable, but they're sort of special cases that show up every once in a while, and you've got to make sure you know how to handle them. Let's take a look at another one. First, I'll make this observation, though, that when you're solving them, use your calculator, which will work for everything except for the undefined ones, or the reciprocal of the undefined ones, excuse me. And then also simple reasoning. The diagram that we went through will help illustrate it, but you should have a fairly clear understanding of why these ones are not working out, or why you're getting the values that you are. Now let's try the next quadrantal. This time theta is equal to 180 degrees. So sine of 180, I'm not going to show you all the extra work on it. I just drive it right through my calculator. Sine of 180 is equal to 0. And this should make sense because whatever the y value is, it will be wherever you are on the x-axis for a 180-degree angle, the y value will be 0. The cosine of 180 is equal to negative 1. Interesting. The tan of 180 is 0. So this time we can actually calculate that one. The cosecant of 180 is undefined. The reciprocal of 0 would be undefined. And then the secant of 180 is equal to negative 1. So the reciprocal of cos of negative 1 is still negative 1. And then you could see, I put them both up, that the cotangent of 180 degrees is also undefined. So when you try to take the reciprocal of 0. Now you're going to get similar patterns all the way around. So when you go to 270, which I didn't bother showing, and then 0 or 360, which I didn't bother showing, you'll get a similar thing, either a 0, a plus or minus 1, or undefined. So I'm not going to expect everybody to memorize them, although the primary ones you probably will memorize. The other ones you may have to think about. But you have to know how to get there, how you can solve these ones. So that's it for this lesson. Thank you for your time.